inverse function. So first of all, how do you check if two functions f and g are inverses? There are two ways. Actually, we discussed one specifically. What was the way to check with composition?
F of g and g of x.
You'd find f of g, and you'd find g of f, and what would they both have to equal? X. Now, another completely legitimate way to do this would be to take the function f and actually find f inverse. Does that also make sense? Now that you know how to find inverses, you could just take the function, find the inverse, and if the inverse is the g function that you're given, then yes, they are inverses. We're going to do one question that way because checking that way is actually easier than checking by a composition for one of the problems we have in class today. In general, how do you find an inverse? So given a function y equals function of x, what are the general things you do?
Just
Change x and y. And then what's the second thing you do? Solve for y. And that forces you to undo stuff in the correct order. Okay. How are the domain and ranges of the original function f and the inverse function related? They're switched. Yep, so the domain of f is the range of f inverse, and the range of f is domain of f inverse. And you can use that relationship to find the domain and range of f inverse. I'll be testing that you can actually do that on the quiz. Okay. That was the next question, but the graph's probably right. How are the graphs of f and f inverse related?
reflected across the axis y equals x.
Reflected across the line y equals x, or we'll say, and that line is a sort of a diagonal line, right? Okay. Okay, so for this next one, determine whether these two functions are inverses. Finding the composition is going to be a little bit gross. Don't write this down, let me show you why, okay? So if I were to find f of g of x, I'd have to do f of 3 plus 4x over 2 minus x, right? That's what that would involve? Okay, just tell me roughly what would you get when you plug that into f? You'd have 2 times a big old fraction, right? And then minus a 3. And then all that would be over
X plus 4. X plus what?
2x minus 3.
Yeah, it's 2x minus 3 over x plus 4. You're putting this thing in for all the x's.
Oh, so we 3 plus 4 is over 2x.
You see you'd have that thing again, right?
Plus 4.
And that would just be like a disastrous, awful mess to simplify.
Yes.
Does that make sense? We're not going to do it that way. That's why I said don't write it down. The other way to find the inverse could be to just, oh shoot, no, I just made it so I couldn't erase, oh well. The other way to find the inverse could just be, or to verify that these functions are inverse, you could just take that function f and find the inverse and show that it is g. Okay, so and that's actually, it's a little bit tricky, but it's not so bad. Y equals 2x minus 3 over x plus 4. And you could do this with either f or g. If you find the inverse of f, you should get g. If you find the inverse of g, you should get f. So, swap the x and y. This is the trickiest inverse question you're going to get, so count on it actually being there. What do you do first? Multiply by, and that will give us x times y plus 4 equals 2y minus 3. And then what? Distribute the x, yep. xy plus 4x equals 2y minus 3. Okay, now what next? Xy minus 2y equals negative 4x minus 3. So I choose to put the y's on the left and the x's on the right. That could be chosen in a different order if you preferred. And then take out the GCF of y. And y will equal negative 4x minus 3 over x minus 2. Is everyone okay with all those steps? We've all done them a whole bunch, you should be. Is that technically right now exactly what we were given as g?
Yes.
It actually is. So it doesn't look the same. Does that make sense? Technically speaking. But this is the same thing, because if you multiply the numerator and denominator by negative 1, what do you get? You get positive 4x plus 3, and you get negative x plus 2, which is the same thing as g. Does that make sense? So in this case, yes, they are inverses. At this step right here, when I decided to put the y's on the left, if I would have made a different decision and put the y's on the right, I would have gotten this answer right away. Does that make sense? Because I would have moved this 3 over, which would have made it 4x plus 3, right? I would have moved this xy over here, which would have made it 2y minus xy. Does that make sense? And so then you would have gotten that one right away. So just watch out. If the answer that you get has the exact opposite numerator and exact opposite denominator of that g function, it actually is the same thing. That's the only tricky thing about finding inverses, checking something's an inverse that way. Okay. So graph the function x squared minus 5 for x bigger than or equal to 0, and verify that this is 1 to 1. So because you added this bit in, you made the function 1 to 1. So what does x squared minus 5 look like? The parabola shifted down 5. And it's the positive half, exactly. Okay, so there is f of x. If that had said x is less than or equal to 0, it would have been the negative half. Okay, now find f inverse and graph it. So that would be x equals y squared minus 5. So you solve that by doing x plus 5 equals y squared, right? And technically, y equals plus or minus the square root of x plus 5. The question is, which one do you pick? So think about it this way. If you had positive root x plus 5, that looks roughly like that, right? And if you have negative root x plus 5, it looks roughly like this, right? You need your f inverse to have what range? So the domain of f inverse is going to be, let's find out. The domain of f inverse is the range of your f, right?
So y has to be greater than 0.
Exactly, yep. So the domain of f inverse is from negative 5 to infinity. Both of those have that property, right? The range of f inverse has to be 0 to infinity. Does that make sense? So which one of these are going to have the y's that are from 0 to infinity, the top one or the bottom one? Top one. So that's the one you choose. You also could, if you graphed the other one, it won't have that reflective symmetry property that's supposed to have. Does that also make sense? So you could put them on both on there and then tell yourself, okay, well, which one is it based on the symmetry that has to exist because they're inverses. But because this said that the x's are bigger than 0 for f, that means the y's are bigger than or equal to 0 for the inverse, because of the whole flip-floppage. Okay. All right, graph this function for x bigger than or equal to -4. That seems like kind of a random value, doesn't it? At least just first looking at it. And then verify it's 1 to 1, and then find f inverse and graph the f inverse in the line y equals x on your graph. All right, so I think the best strategy for graphing that parabola is to complete the square. So f of x is x squared plus 8x. It's even an easy one. So completing the square says that you add half of the coefficient of the linear term squared. So half of 8 is 4. 4 squared is 16. So you plus 16. And you have to be fair and compensate and actually have cleverly added nothing. So what do you subtract? 16. We had other problems where we had like a negative out in front of it and stuff, and that was more tricky. This one's an easy one. And then that becomes x plus 4 squared minus how much? 9. And I know my grid only goes to 7, I'm sorry. So this is a parabola shifted backwards 4 and down 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. Okay. Where is that parabola going to cross the y-axis? You cross the y-axis when what's true about x?
Equals 0.
So when x equals 0, what number comes out of that equation?
-9. 7.
7. If you put 0 into the one that's been completed, you'd have 16 minus 9. Does that make sense? Okay, so that would be 7. And we only keep the parts where x is bigger than or equal to -4. So just that half. Does it make sense that for parabolas, the reason they had to put that dividing point at the vertexes is if that's the point that will divide it into equal halves, and if you didn't do it there, it wouldn't be 1 to 1. Okay. So what is the domain of f? What's the leftmost x? And what is the range of f? Lowest y. -9. Great. Now it turns out that in addition to graphing, the form where the square has been completed is also the easiest one to solve for y in once you flip-flop the variables. So when you write this as x equals y plus 4 squared minus 9, that's actually the easier way to solve it. So how would you solve that? Add 9, yep. So x plus 9 equals y plus 4 squared. Okay, and then what else? Now what? Square root it, yep. Technically, plus or minus the square root of x plus 9 equals y plus 4. And so what y will equal plus or minus that square root of stuff? -4. Of course. Is that enough? Okay. So if I were to graph those square roots, I would shift left 9, right? And then what? Down 4. So if I go left 9, 8, 9, down 1, 2, 3, 4. And the plus part of that would be the square root that kind of went up. Does that make sense? The minus is the one that goes down. Which one's going to have the right reflective property so that it's the inverse? The plus. Yep. So it'd be the one that goes up. So your F inverse of x is root x plus 9. I don't know why I put a little habit. For some reason I thought x squared. Root x plus 9. And then minus 4. So just one more reminder that you probably have to be able to graph a parabola using completing the square. So just remember that. Okay, how about this one's weird? Okay, this next one. My guess is most of you don't remember what the graph of square root of 9 minus x squared looks like. Is that fair? Okay. It is definitely something that you should, by the end of this class, be able to recognize. I'm going to try to bring it up again and again because it does happen in Calc 1. Let me write it in a different way. Let's write it as y equals root 9 minus x squared. If I square both sides, I get y squared equals 9 minus x squared, right? Does that make sense? Which is the same thing as x squared plus y squared equals 9. Recognize it now? It's a circle of radius 3 centered at 0, 0. Now, the fact that you had a positive square root means it was the top half of a circle, right? So top half. So I'm going to draw this and we're going to erase. So if you want to sketch it in after I've erased, that's totally fine. So there's my top half. Is that top half of a circle a 1-to-1 function? No, it's not. So there was this additional restriction that x is between 0 and 3. So which half of the circle do you keep? The left half or the right half?
Right, just the right half.
The right half. Okay, so I'm going to erase the part we're not keeping. There we go. So if you see number minus x squared, you should think semicircle. Does that make sense? That's going to happen in calculus, specifically chapter 5, section 3, maybe section 2. Is anybody a little bit impressed? I remember that? Okay, no one cares. All right, so there is the graph of f. What is the domain of f? What is the leftmost x? And the rightmost x is? What is the range of f? What is the lowest y? 0. Highest y is? 3. Okay, so let's find the inverse. So we'll have x equals square root 9 minus y squared. Square both sides. What do you want to do next at that stage?
Add 9. Or add a y.
Add y? Sure. X squared plus y squared equals 9. And then what next? No, you have to get the y by itself. Subtract x squared. And then take a square root, right?
That just brings us back to the original equation.
Interesting enough, right? Yeah. So, and you take the positive half because of the whole domain and range of f thing. If you draw in that diagonal and you think about the whole reflecting property, does that seem like it's plausible that this function is its own inverse? You see how this half would reflect up there and that half would reflect down there on top of itself? So in that case, it is. It is its own inverse. So that's why I did that one, because I figured you'd be weirded out by the fact that you got back the same thing. Does that make sense? Just as an aside, okay, so I'm going to draw another one. What if I'd taken this part of the circle? Okay, like what if that was my F? And using that whole reflection business, where would what quadrant would F inverse lie in?
4.
4. It'd be over here. And so for this one, this is F of x would equal square root 9 minus x squared. What would be the x's that you would use for that one? -3 to 0. That would be the domain. Because this F inverse equation, because this falls below the x-axis, what would it have to be? It'd have to be minus the root. Does that make sense? And then you'd have to give it domain. So this is the domain of F. The domain of F inverse would have to be from 0 to 3, right? Does that make sense? Okay. So the picture can also help you, give you a clue as to which one of the whole plus minus businesses you should pick. I'm not sure if the homework questions get that tricky on Alex, but just a good way to check if you're reasonably right would be to look at a graph. Okay.
What would you call a function that is reflected over -x equals y?
I don't know if it has a specific name. So there might be some other. I mean, it's definitely not an inverse. I don't know if two functions that have this reflective property over y equals -x. I'm not sure if they're. And a reasonable question would be: does that also imply that there's reflectiveness over y equals x? I don't know. I need to think about it more. Okay, this function is 1 to 1. I'm just telling you that it is. Okay, accept that. Now find the inverse. So x equals 5 minus 4, or plus, excuse me, 4 over y. How would you guys, what would be your first instinct for how to start this?
Common into 5.
Okay, so I have a couple things. I'm hearing times by y, somebody else said, common denominator, whatever else say.
I'm thinking moving 5 to the other side.
Okay, they're all gonna work, okay? Does that make sense? It's all going to work. I'm going to pick the times by y one, okay, because I like that one the best. But it would work to -5. It would work to get a common denominator, okay? Those are all legitimate methods. Here's why multiplying by 5 is kind of cool, or by y is kind of cool. That y distributes, and you get xy equals 5y plus 4. Does that make sense? Multiplying by y on both sides of the equation, that's what happened there, right? Allows you to cancel out the y's. Now you take away 5y, get the y's on the same side. And then what next? Take out the y. And y will equal 4 over x minus 5. F inverse is 4 over x minus 5. Okay, there's way 1. So Tristan, you said you would take away the 5 first, right?
Yeah, move 5 to the other side.
Yep, so here's what that would look like. Does that make sense to everybody? And then what would you do next?
Then multiply both sides by y.
So that'd be y times x minus 5 equals 4.
And divide x minus 5.
Yep. Same answer, right? Okay, somebody else said you would get a common denominator, right? For those of you that said common denominator, would you get a common denominator on the left side too, or just the right side? What do you think?
I do all.
You do all? Okay, all is a good method. So that would be x times y over y equals 5 times y over y plus 4 over y, right? And once the denominators are all the same, you can multiply by the denominator and make it cancel, right? Does that make sense for you to say common denominator? So that's xy equals 5y plus 4, and we're at the exact same step we were at here. Does that make sense? Okay, so all of those methods will work. I would just suggest if you do common denominator, get a common denominator across the entire fraction, at which point in time you can multiply by it and it goes away. So, technically speaking, I think that, I mean, this method, the first one we did was okay, but I was a little bit wrong. I think Tristan's might be the fastest. Do you guys agree with that?
Probably.
Probably, yeah. Okay.
Because can't you just switch the x minus 5 with the y, switch their places?
Yes. Wait.
You don't really have to do this.
Oh, yeah, you can kind of just switch their places because it's kind of like yeah, sort of. Yep, okay. Let's find the domain and range of F inverse. So domain of F inverse, range of F inverse. So the domain of F inverse, you can just find by looking at it. What number has to be left out?
5.
Yep, x cannot equal 5. And unless I specify on the directions to use interval notation, you can just give it that way. For the range, y can't equal one thing, and is it easier to look at F inverse's equation for this, or is it easier to look at F's equation for this? Look at F's equation. So remember that this is the domain of F, and what's the one thing x cannot equal from F? 0. So y won't equal 0. If you do give your domain and range in terms of what variables cannot equal something, you must say x for domain and y for range, because the domain are the x's and the range are the y's, right? If you give them as intervals, that's sort of implied. Like you just say negative infinity to 5, union 5 to infinity, and negative infinity to 0, union, that was a terrible u to 0 to infinity. So either way is okay. Okay, I've done a gazillion of these. How about you'll see if you can do one? Give it a shot. Anybody finish yet? Did you get that? Did your answer look a little bit different? What would be one other way to write that? Did we get the same thing as me?
I had negative 2x over x plus 5.
So is Willow also right, guys?
Yes.
Yes, she is, okay? So the way to get from my answer to hers is that you could multiply the numerator and denominator by -1, right? So the step at which our answers, they're equivalent, but the step at which they're different is that probably at this stage, she chose to put the xy over there.
Shouldn't the 2x be negative since you had to subtract from both sides?
Oh, whoops. I was just testing if you guys would catch my mistake. Yep, that should be negative. That should be negative, so it should be positive 2x over x plus 4. Is that right?
Oh, yeah, I made the same mistake.
You made the same mistake as me? Well, hope it makes you feel better.
I made that mistake enough times.
Yeah, no, you're totally right. Do you guys see what I did wrong? This 2x, when I moved it over, it should have been negative 2x. I apologize, but yeah. Good catch. It's really been candy when you make good catches on my mistakes, and I should, like, pass it out. That keep you awake, right? Today's been good.
I actually did not feel the urge to actually fall asleep for the first time in like forever.
I know, right? It's amazing. All right, try it again. Do this one, all right? We'll see if I can successfully not make that mistake again. Did anybody else get 5 minus 7x or 3 over 3 minus 4x?
That's what I got. Okay.
It also is, so what is another way that this could look that's also correct?
7x minus 5 over 4x minus 3.
Does that make sense to everybody why it's also okay? All right. I didn't put this in the directions, but I am positive it's on your quiz. Find the domain of F inverse and find the range of F inverse. So for the domain of F inverse, what's going to make that 3 minus 4x equal 0? Is it
4/3?
9? 3 equals 4x? 3/4. Yep. So x can't equal 3/4. So for the range of F inverse, we're looking at when does 7 minus 4x equal 0, because that's the domain of F. That's going to be 7 equals 4x, and so y cannot equal what number? 7 over 4.
So on the quiz, will we have to write them in interval notation?
Let me double check what I did. What was quiz number? I gave it both ways. So if I didn't specify in directions, either one's okay. If you have spare time, you could just give both, just because it's easy. Okay. All right, one more on this page. Given that f of x is the cube root of x plus 3 minus 2, so this is a S-shaped function, right? Shifted that way 2, and that way 3, and down 2, right? And those S-shaped curves are, those sideways S's, they're also 1-to-1, right? Okay, so you can find the inverse. So start by swapping the x and y. So x equals cube root y plus 3 minus 2. Well, first, add 2, yep. X plus 2 equals cube root y plus 3. And then cube x plus 2 cubed equals y plus 3. You don't actually have to cube that out, okay? If you do, it's all right, it's going to be long, and you're probably going to make a mistake. Not that I don't believe in you. Then you move the... And you get x plus 2 cubed minus 3 equals y. So f inverse of x is x plus 2 cubed minus 3. Do you guys know what I mean by expand x plus 2 cubed? As in do x plus 2 times x plus 2 times x plus 2. That form is more useful for some things, but this particular form is more useful for graphing. Does that also make sense? Because you could shift the picture. It's a cubic shifted backwards 2 and up 3, right? What's the domain of f inverse going to be? Think about this as just in terms of stuff you can't do. Are there any numbers that you can't cube? No. So that domain is all real numbers. And for the range, think in general that cubed curve looks like this, right? Its range is all real numbers. Does shifting it around change that? No, it's still all real numbers. So. Okay, so I think we're pretty good with inverses that are just these kinds of things, right? Now the next thing we have are a couple application questions. And in application questions, the letters have very specific meanings. This is one case where you really don't want to switch. Okay, so when you have a problem that has words and the variables have meanings, don't switch the variables. And you can think about that whole Fahrenheit Celsius formula we had, like from the very first day. I gave one that was F equals and one that was C equals. Does that make sense? So with word problems, don't switch. So this formula is used to estimate, I didn't circle my H, sorry, is used to estimate the body, what should that say, probably? I should say weight, as a function of height. People that are taller tend to weigh more because, you know, they have more bone, more muscle, all that stuff. So P is the weight in pounds, and H is the height over 5 feet in inches. So this equation, as we're given, you input H, and you get out an estimate of weight, right? The inverse, sorry, you can't see that. With the inverse, you're going to input a weight, and out's going to come an estimate of that person's height. Does that make sense? So take that equation, P equals 100 plus 5H, and just solve it for H. So first step, minus 100, yep. Next step could be to, if I say H equals 1/5 P minus 20, does that make sense?
Yes.
So what I did there is this really is 1P, right? Divided the first term by 5 and the second term by 5. So that is H equals W inverse of P. That's the inverse function. Okay. Now its domain. So this domain is the range of P, right? Now this specific model specified that to be a member of this model, you had to be taller than 5 inches. 5 inches. Got 5 feet in inches, right? So H is height over 5 feet in inches. And one of the reasons probably is that children are special. They tend to just be skinnier because they have, you know, well, less muscle and for girls haven't hit puberty. Oh, those were the days. So if you are 5 feet exactly, what number goes in for H? 0. Does that make sense? So the domain of P is 0 to technically, I mean, infinity isn't really, you can't be infinitely tall, but I mean, I don't know what to put as upper bound, so we'll just say infinity. The range will be, when you plug in 0, what do you get for a person's pounds? 100. And if you think about what that thing looks like, it's a line, right? 100 plus 5h. It has y-intercept of 100 and then slope of 5. What happens to it as you plug in bigger and bigger h's? What does it do? Does it go up or down? It goes up, right? So this first number is going to be your lowest number. So this domain is 100 to infinity. So the skinniest weight you can input to predict somebody's height is 100 pounds. Oh, those little midget people. Okay, but most important thing with the word problems is don't switch variables, please. Okay, one more because you're going to make CD players, right? Yes, maybe? No. Okay, well, how do you know the future? I have a friend who lives in Bahrain, which he's in, like, he does geological engineering, but he makes speakers out of marble because he thinks it's fun and sells them for lots of money. He's got a lot of spare time.
That does sound like a lot of fun.
Yeah, so you never know. So the quantity Q of CD players a retail chain is willing to supply at a price P is given by this equation. So Q probably stands for quantity, P stands for price, and specifically for prices set between 10 and 70. Now, I just graphed this to verify what it looks like. And between 10 and 70, the function looks something like this, like it's going up. So just have to kind of believe me that that's what's happening. So find the range of S. Does it make sense that the domain of S is 10 to 70 because I told you that those were the possible inputs? Because this picture is increasing, for the range, the lowest y will happen at the left endpoint. Does that make sense? And the highest y will happen at the right endpoint. So the range of S at a price of 10, Q is going to equal 9,000 over how much? 30. Did you guys learn in elementary school that you can just cancel zeros? Mm-hmm. Okay, so I'm never sure because some people don't seem to know that. What is 900 divided by 3? 300. And how about at a P equal 70? So what will 70 times 900 be? What's
63 with 4 zeros.
Does anybody want to revise this answer? You sure 4 zeros?
3.
I think 3 zeros. Multiply the 9 and the 7, right? Which gives you 63. 1 0 from the 70 and 2 zeros from the 900.
Oh, I was looking at the 9,000.
Okay. You were looking at the one above. That makes sense. Okay. Divided by, what's my denominator going to be, guys? 90. So once again, do the whole cancel a zero thing. So 9 goes into 63 7 times. And you got that followed by how many zeros? 2. Same number, right? As above. Okay, so the range of S is 300 to 700.
When you have to make an exception for negative 20. Oh, no, that's not within the restrictions, so you wouldn't have to.
Yep, exactly. You wouldn't make and also negative 20 wouldn't make sense as a price because like you would never set a negative price. You're not going to pay people to take your stuff usually.
Gifts.
is whatever. Okay, so moving on. So the point is that one thing I think that's a little bit confusing is that the book didn't tell, if you didn't know that that function q was always increasing, there's no way to tell that the highest point didn't happen someplace in the middle. Does that make sense? So I think that what you should do for problems like this, and you can pretty safely assume that the function is going to always increase or always decrease because those are the kind of problems you're going to be given. If you feel like checking, there are all sorts of online graphics you could plug that into and get a picture of it. Does that make sense? And you could also put in the vertical lines x equals 10 and x equals 70 and just look at that part and see if it is always going up or always going down. Okay, that would be what I would suggest. Okay, find the inverse function and find its domain and range. So for this particular function we have, we input price and what comes out? Out comes Q, which is the quantity. The inverse will do the opposite. You'll input a quantity and out will come the price that you're going to pay. So in this case, don't switch the P's and Q's. I apologize that they look somewhat similar. But just take that equation and get the P by itself. Yeah?
So why isn't it just the opposite of what we did in part A?
Why? Oh, the domain and range will be the opposite, but we have to actually find the inverse.
Oh, so we have to actually show the work for that?
We haven't yet found the inverse equation. Does that make sense? But you are right that its domain and range, we will use the answer to part A. No, you're totally fine, not a problem. Q times P plus 20 equals 900P. We're getting P by itself, right? So I have to get the P's in the same side, so not yet. QP plus 20Q equals 900P. And I'll just add myself a note. Get P alone. That's what I'm doing, because otherwise it's easy to lose track of what's going on. Okay. So let's put the P's on the left. QP minus 900P equals minus 20Q, right? Factor out your P. And P equals negative 20Q over Q minus 900. What's another way you could write that? If I made it positive 20Q, what would the denominator become?
900 minus Q.
900 minus Q. So either one of those is okay. And Willow is right that the domain and range of this function we actually found in part A. So what would the domain of this function be?
10 to 70. 370.
300 to 700. You switch them, exactly. The range would be 10 to 7. You can think the output are your prices, right? The input are your quantities. Okay. So that's it for inverses. So we're done.